Hello everyone, welcome to our pre-calculus lesson. This is our lesson 22, graphing quadratic functions using transformations. So this is another way of quick graphing actually. Sometimes we draw the graph by using our conventional ways, like think about some values of x and then what will be the value of y, then plot it on the graph paper and then draw it. But by using the transformation, we can actually quickly draw the graphs by using some techniques. We will try to discuss them here. These are the these are the agenda. So basic quadratic functions and transformation for quadratic functions: flip, stretch or compress, vertical shift, horizontal shift, and then vertex form, form to graph and graph to vertex form. So these are the agenda. Let's look. So the basic form of quadratic functions, this is ax squared plus bx plus c, where b and c can be 0, but a should not be 0. A has to be some numbers always. Okay, not 0. Some number means not 0. Other than 0, it can take anything else. This is the graph of the quadratic function if the value of a is positive. And this is the vertex. This is the vertex. This is the line of symmetry. And where do you use it? Area of an object, acceleration, including the gravity, this kind of thing. These are the application. Where do you apply it? Revenue, money related maths. Now the transformation part. So the simplest quadratic function is fx equals to x square. The graph of the fx equals to x square is this one. And you can try to draw the graph just to verify if this is the graph or not. You can think about if x equals to, let's say if x equals to 0, what is the answer of y, what is the answer of fx. Here it is fx and y is, they represent the same thing here. So if it is 0, then what is the answer? It is 0. If it is 1, what is the answer? It is 1. If it is 2, what is the answer? If x equals to 2, answer is 4. So this way, if you continue, you get if x equals to 0, 0. If x equals to 1, 1. If x equals to 2, answer is 4. See? And if you think about minus 1, if x equals to minus 1, answer is plus 1. If x equals to minus 2, answer is plus 4. So this is the minus 1 point, this point, minus 1 comma plus 1. This is minus 2 comma plus 4. This is minus 2. Then this is plus 4. Then if you join all the points, you will get this graph. Okay. So this way you can show that this is the exact graph of this function. And the other information, as you can see here, the vertex value of you can think about if x equals to minus 2, minus 1, 1, etc., etc., then what is the value of the fx. By using that, we can actually draw it. Now, what are the ways by which we can change it? What are the transformation that we can do with this graph? We can change the sign. We can give a negative sign before this x square. Okay. We can change the coefficient of x square. Like we can write here 3, 4, 5, 3x square, 4x square, 2x square, like this, or 1 by 4x square. You can write like this. Then we can add some constant number after this x square. So we can write x square plus 2, x square plus 4, like this. Then we can do something inside the bracket, x minus 4 whole square, x minus 2 whole square. Or we can actually combine all of them. We can do everything together. So these are the things that we can do with this x square. And if we do this kind of changes here, if we bring this kind of changes here, this will change the graph. And transformation is the study of how all these changes change our graph. So let's look at what type of change we will see. So this is the x square graph. If you give a minus, the graph will flip about the x-axis. The graph will come down. So this will be the minus x square graph. This is the plus x square, this will be the minus x square. This is the reason is due to that minus, all the value will be negative now. All the value will be negative now due to this extra minus. Okay. So vertex do not change, as you can see. So if in the form ax square, if a is positive, then graph is upward. If a is negative, then the graph is downward. A is negative means this sign is negative, or the number that comes before this x square, if that number is negative, then the graph will be down opening. This is called down opening. This is called up opening. Now see what will happen if you put some number, additional number with this x square, 2x square, 4x square, like this. In that case, the value that we put here, after multiplication, the value will increase faster. If you multiply it by some 2, 4, 9, the more value you put here, the total value will increase by the multiple of that number. In other words, it will increase too fast. So you see, this is the graph of 2x square. This is the 4x square graph. See, it increases too fast. You see, this one is the regular x square graph. When you multiply by 2, the graph comes here. When you multiply by 4, the graph comes here. The graph becomes little bit squeezed, little bit compressed. Okay, the graph gets compressed here. And the reason is simple. If you put normally, say for example, if you put 2 here, then answer is 4. But if you put 2 here, so 4 into 2, that means now answer is 8. So answer becomes bigger all of a sudden. Answer becomes bigger. So that means at 2, now this line will intersect at 8. So it is going much higher than this graph, or it is compressed to balance the change. Same goes with this number. And if you put here 1 by 2, 1 by 3, then it will be actually wider, more wider. Then the graph will become more wider. This is half. This is 1/4. That means 0.25. So the graph will become more wider. This is the red color graph. Okay. So this was our main graph. This one, this blue color. If you multiply by some number like 2, 3, 4, 5, 6, if you increase it, then the graph becomes compressed. If you go to the decimal numbers like 0.2, 0.3, 0.4, this kind of thing, this is 0.5, just to give you an example. This is 0.5, this is 0.25, and this is 0.25, so 25 of x square. So you see this number is smaller, that's why the graph is more wider. If the number becomes more, then the graph comes to this side. The graph gets compressed. The graph gets compression. Compression happens for that. Okay, compression happens for that. Vertex remains the same, and if the value is more than more than 1, then the graph becomes narrow. If the graph is less than 1, that means 0 point something, and more than 0, of course, then the graph becomes wider. And same thing goes with the negative side. Now it will happen for the negative side. Same thing will happen for the negative side. Negative side will same thing will happen. Just for the negative, the graph will have a flip. The graph will give a flip. Okay, which graph is here, which graph is there, this kind of thing. Suppose this is negative, so there has to be in the negative side. This is positive, so there has to be somewhere there. And this is 0.2, so it has to be wider, like that. This is 3x square, so it has to be compressed. So this is the graph, like this. Just the idea, developing the idea. Of course, here also you can always draw the graph as always to verify if your answer is right or wrong, but it takes time to do that. Now vertical shift. If you add some number, x square plus 2, x square plus 3, x square plus 4, for some positive number here, this exact same graph will go up. If it is plus 2, then it will go 2 box up. 2 unit up. If it is minus 2, then it will come 2 unit down. Minus 3, it will come 3 unit down. The whole graph, the entire graph will come 2 unit down. Just like this. It is for the plus 2, so it goes 2 unit up. If it is minus 3, the whole graph will come 3 unit down. Okay. Now here in this case vertex also changed. You see, the vertex was here, now the vertex is there. So the vertex changed. So x square plus, this is the rule, x square plus k. If the k is positive, then the graph goes up. If the k is, goes up, and if the k is negative, then the graph comes down to this place. Now, in contrast to the previous change, we can change within the bracket also, x plus 2 whole square. This is different type of change. This is called horizontal shift. So the graph will now move left and right. If this is plus 2, then graph will come here at minus 2. Opposite, for the horizontal shift, it will take the opposite effect. So the graph will come here. X minus 3, so it will go to the plus 3. It will go here. Okay. Vertex change, of course, vertex change. So you see, if the positive, then the graph will go to the left side. If the negative, then the graph will go to the right side. Okay. The reason is we need to cancel out the number. Suppose here x plus 2. Why the graph comes to negative 2? Because what number you need to cancel out this plus 2? You need a minus 2 here. That's why graph comes to the minus 2 part. You have to think what number we need here for x to get us 0 here. The whole thing 0. To understand where the vertex will go. Okay, this is why it takes the opposite, it goes to the opposite direction. If x equals to 0, then x equals to minus 2, it comes. If x equals to 0 means y equals to 0. And on this point, on this point, on this point, everywhere on this line, you have y equal to 0 because they are on the x-axis, that's why. Same thing goes with the other lines. Now vertex form of a quadratic function. This is called the vertex form of a quadratic function, a into x minus whole square plus k. This is the vertex form rule. So far you have learned a standard form. The standard form is ax square plus bx plus c. This is the standard form of the quadratic function. We said that a cannot be 0 at the beginning of today's lesson also. So a cannot be 0. So this is one form. This is called the standard form. We have to write fx equals to here in this side just to make it a function. So this is the standard form, and then this is the vertex form. Still, it is also quadratic. This is also quadratic. You see x whole square. You have x square here. All the numbers here is actually at different places. Some number here, some number here, some number here. This is because to draw the graph of quadratic function, actually this vertex form is very helpful. This vertex form. Okay, because from all this number we understand what is going on, what will go on with this graph. See, let me tell you that first. So for this plus 3, which is the value of k here, the graph will go 3 unit up. For this minus 1, x plus 1 within the bracket, the graph will go 1 unit down, 1 unit to the left side. So it will go to the minus 1. It will go to the plus 3. Go up 3 unit up. For this 0.5, the graph will be wider. The graph will be wider by a factor of 0.5. The graph will be wide. For this minus, the graph will have a reflection about the x-axis. Graph will flip. Wherever it goes, it has to reflect now. Now see what happens for this graph. See, this is the change for this plus 1. Now for this plus 3, the graph will go 3 unit up. Then for this negative sign, the graph will flip. and for this 0.5 the graph will be wider. Okay, let me show you once again. So first of all, for this plus 1 the graph goes to the minus 1. For this plus 3 the graph will go to the 3 unit up. For the negative sign the graph will flip. For the 0.5 the graph will be wider, like this. So if someone write the question in this form, actually we can move the graph due to different numbers. We can move the graph at different places, and this is very easy if the question is written in this form. Okay, so this is how vertex form helps us. Now how the graph will look like: x square plus 1, so the graph should go 1 unit up and then line and the graph like this. So something like this, x square plus 1, so the plus 1 is here, so the graph will be something like this. It will go through 1. Then x plus 1 whole square, so x plus 1, so the graph will come to the minus 1, so the graph will something like look like this. This graph this way, x minus 2, so the graph will come to the plus 2. Still it is plus. This is x minus 3, then minus 3, so the graph will come to the minus 3. 1, 2, 3. This is minus 3, so the graph will come to the plus 3. 1, 2, 3. The graph will come to the plus 3, and for the negative sign the graph will come here for the negative 3, and there is a this is positive, so the graph will be up opening, so some kind of like this. Okay, so for all this number actually we can move our graph at different places. See, this is the first graph, this is the second graph, this is this color graph. I did not draw it. This is the another graph that I tried. Then the red colored graph is somewhat here. So for this all the numbers actually we can draw them. We can transform them. Okay. Now more questions here. How the graph will look like. So it is plus 1, then 1. That means the graph will go 1 unit up, 1 unit to the negative side. Then the graph will be negative. So this graph will be something like this. Something like this. It will go here and go here. Something like this. Then suppose this last one, minus 3x minus 4 whole square, then minus 2. So for this minus 4, the graph will go to the plus 4. 1, 2, 3, 4. Okay, here. Then for this minus 2, the graph will come 2 unit down. Okay, here. Then this for this minus 3, the graph will be down opening. And for this down opening and for this 3, the graph will be little bit compressed. So the graph will be something like this. It will continue. We can actually extend it. So let's repeat to understand that if we are doing it right. So for minus 4, the graph will go to the plus 4. For minus 2, it will go to minus 2. Then it is negative. So it is it will have a reflection about the x-axis. Then minus then for the 3, it will have some effect. So this is the first one. See, our approximation is correct. Then if we do it the other part, these are the other parts, and the red color one that we have drawn, this is the red color one. Okay. You try to draw this graph without seeing the answer first, then match your answer and our answers if they are going to the right direction. This is the best way to practice it. Okay. So here this is the opposite thing of what we have seen here. So in the previous slide, all the questions are given. You have to draw the graph. Here the graph is given. You have to come to the question. So this kind of math. Ax minus h whole square plus k. So this way we can do. And x this k is the where the graph is. Okay, k is the value of where the graph goes up or down. Up down is the k value. H value is the left right value. Where the graph is it in the left side? Is it in the right side? Where is it? A is the number that we need to multiply to get some, like, is it wide or is it compressed, to get that idea. So this is the blue colored line. This is 2, this is 3. So let's see. This is the vertex is, this is minus 3, comma 2. So this is minus 3 comma minus 3 comma 2. This is minus 3 comma 2, and this point is minus 1 comma 0. Okay, so you may ask, sir, how do we know this number? This is slightly tricky, so that's why if you want to get this number, we can actually know that this sign will be negative, so that way we actually know that. And then other thing also we know, but just to do it manually, you can just put all this value here. Let me show you this first one. So fx equals to, suppose the value of a we do not know, then x minus h whole square. So you see x minus h means this is the h, this is k, because it is vertex. So x minus minus plus, so plus 3 whole square plus k, k means 2. Now see, still we are saying that the value of a we do not know. That's why I have taken one more point here from the same graph. This point is also on the graph, minus 1 comma 0. This is the x value, this is the y value. So you write minus 1 in the x value. Here you will write minus 1. This is, instead of x you write minus 1. Instead of y, this side is y, you write 0. Okay, you write 0 here. Then you do the calculation, what is coming here. This 2 will come to the negative side, then we can write it like minus 1, 3 minus 1 equals to what? 2 whole square means 4, so 4a. So this is 4a. Okay, this is 4a. Then this is plus 2 equals to 0. This side is 0. So a equals to what? A equals to minus 2 divided by 4. So minus 2 divided by 4 means minus half. Okay, so that's why we got this minus half. And 3 comma 2 we got this from the vertex. From the vertex we got this 3 comma 2. This 3 and this 2, and this point we get this way. Now you can say, sir, you choose this point. Is it necessary that we have to choose a point from the x line? Answer is no. You can choose any points from the graph, any points. But when you choose any points, try to choose a point which is easier for your calculation. That's it. Okay. Suppose for this graph, there is no x-intercept, so that it is obvious that you have to choose this point for best calculation. But if you want to choose this point, answer will come correct. If you want to choose any points, answer will come, But the problem is, let's say if you choose this point, then this is a decimal point, so it is not a good point to do the calculation. This is what I'm saying now. You have to choose a good point, okay, for your calculations. Then the calculation will be easy. You will get a perfect answer. These are the other answers. Feel free to solve them and then try to match our answer and your answer. Okay. And this is the homework. So we have given a couple of graphs here, and you have to write, like, is it A, B, C, which one is matching with these given questions. Okay. So we may give similar one question in the participation or homework also. So that's all for today, and these are some few more maths. Give a try to solve them, and you can ask questions if you have during the class. That's all for today. Thank you all. Thank you very much. Bye everyone.